Alright, so I think this is recording. Let's take a look at skill 8D where we're looking at complementary angles. We have a complementary angle theorem that says that the cofunctions of complementary angles um, are equal to each other. If you have sine and cosine, they are cofunctions, and I should say cosecant, shouldn't it? All right, sine and cosine are cofunctions, secant and cosecant are cofunctions, tangent and cotangent are cofunctions. So it's asking us to determine the sine of 38, not the actual ratio, but to find another trig function that's equal to the sine of 38. Well, complementary angles add up to 90 degrees, so if we take 90 degrees minus 38 degrees, then we'll have 52 degrees. And since sine and cosine are cofunctions, and 38 degrees and 52 degrees, if I've done my subtraction right here, are complementary. So there's our answer for number one. And we're just going to continue this idea on all of these. So for cotangent and tangent, they are cofunctions. Uh, take 90 degrees minus 57 degrees, and 33 degrees is probably that. So if I've done that subtraction correctly, then the cotangent of 57 degrees is equivalent to the tangent of 33 degrees. The cotangent and tangent are cofunctions. 57 and 33 are complementary. Let's move on to the next one. Pi over 6. Pi over 2 is equivalent to 90 degrees in radian measure. Pi over 6 is 30 degrees pi over 6 radians is equivalent to 30 degrees, and 90 minus 30 is 60 degrees, and that's pi over 3. Now, if you don't have that memorized, then multiply this by 3 over 3, and you get 2 over 6, and 2 over 6 reduces to 1/3, so this is pi over 3. So now this one I don't have memorized. When I have pi over 2 minus 5 pi over 12, I need a common denominator. See, that's 90 minus this. That's how I'm finding complementary angles. I need a denominator of 12. And so now 6 minus 5, this is pi over 12. So the sine of 5 pi over 12 is equivalent to the cosine of pi over 12. Sine and cosine are cofunctions. 5 pi over 12 and pi over 12 are complementary angles. Tangent and cotangent are cofunctions. Pi over 2 minus pi over 4 is pi over 4. Because pi over 4, I'm sure you can think of it quicker in degree measure. 45 degrees plus 45 degrees is 90. So pi over 4 is its own complement, and the tangent of pi over 4 is equivalent to the cotangent of pi over 4. Now this time, they don't give me the radian measure in terms of pi, but I know that's a radian measure because there's not a degree symbol there. So I'm still going to take pi over 2 minus this value. It's just that I don't have to get a common denominator. Well, I guess you could. I'm going to just jump to the calculator and get a decimal approximation for this. So I'm going to go ahead and let the calculator handle the pi for me. I'm not going to have round off error. Well, I guess it is round off error to the number of digits that are displayed on the calculator, but I just let the calculator do the work. If I let the calculator round for me to 3 decimals, because they gave me that radian measure in 3 decimals, so I'll just keep giving it to them in 3 decimals. 0.950. So cosine and sine are cofunctions, and 0.621 and 0.950 add up to approximately pi over 2. All right. Now, we know that secant and cosecant are cofunctions, and that that 90 degrees minus 22 degrees, 68 degrees, and but in our skill notes, we on the theorem itself, we only put sine and cosine and tangent and cotangent, so that on this homework you can kind of derive the fact that secant and cosecant, that this is going to be 68 degrees. But let's go ahead and derive that on these steps here. Secant and cosine are reciprocals of each other, so the secant of 22 degrees is equal to 1 over the cosine of 22 degrees. Our theorem in the skill notes told us that cosine and sine are cofunctions, and that 22 and 68 are complementary, and sine and cosecant are reciprocals of each other, so the cosecant of 68 degrees is equivalent to 1 over the sine of 68 degrees. So there's our answer for this one. And the next one is a similar idea, just for cosecant. So pi over 6 and pi over 3 are complementary angles, because if you, why did I say pi over 3 and wrote pi over 6? If you take pi over 2 and you subtract pi over 6, you're going to get pi over 3. Get a common denominator. 3 minus 1 is 2, but 2 over 6 reduces to 1/3. So cosecant and secant are cofunctions. Pi over 6 and pi over 3 are complementary. So I know that that's going to result to that, but let's go ahead and derive it. Cosecant and sine are reciprocals of each other, so the cosecant of pi over 6 is equivalent to 1 over the sine of pi over 6. Sine and cosine are cofunctions. Pi over 6 and pi over 3 are complementary, and cosine and secant are reciprocals of each other, so we get that answer that we were expecting. All right, so let's take a look at the, now on the bottom part of that homework page, it gave you 6 different ratios of these trig functions, and it's asking us to use those to determine. I just took another block of 6 here. So cosine of 45 degrees, I look among the list, they don't have cosine of 45 degrees here, but I know that the cosine of 45, I know cosine and sine are cofunctions, and 45 degrees is complementary to 45 degrees, and it does tell me that the sine of 45 degrees is radical 2 over 2. All right. So on the sine of pi over 4, it doesn't give me the sine of pi over 4, but it does indirectly, because I know that pi over 4 radians is equivalent to 45 degrees. So the sine of pi over 4 is the same thing as the sine of 45 degrees. And it tells me that the sine of 45 degrees is radical 2 over 2. The cosine of 15 degrees, I look among the list here and I don't see 15 degrees, but I know that 15 degrees is complementary to 75 degrees, and they do give me the sine of 75. Cosine and sine are cofunctions, and 15 degrees and 75 degrees are complementary, so the sine of 75 is given to me as this fraction, radical 6 plus radical 2 over 4. Alright. The cosine of 30 degrees. Well, I look among here and it doesn't give me cosine of 30 degrees directly, but I do know that 30 degrees is equivalent to pi over 6 radians, and it tells me that the cosine of pi over 6 radians is equal to radical 3 over 2. So the cosine of 30 is equal to radical 3 over 2. Alright. Alright, I'm back. Pi over 3. Well, I don't see the sine of pi over 3, but I know that sine and cosine are cofunctions, and I know that pi over 3 and pi over 6 are complementary angles, so the sine of pi over 3 is equivalent to the cosine of pi over 6, and it tells me that pi over 6 is the square root of 3 over 2. I knew that pi over 3 and pi over 6 were complementary because if you get a common denominator of 6, then 3 pi minus 2 pi is 1 pi, and 3 times 2 is 6. The cotangent of 30 degrees, I look here among the lists and I don't see 30 degrees, but I do see the tangent of 60. Cotangent and tangent are cofunctions, and 30 degrees and 60 degrees are complementary. So the cotangent of 30 degrees is equal to the same as the tangent of 60, and it tells me the tangent of 60 is radical 3. Hope that helps, and I'll do the next block, which is identical. It's still using these. It's basically the same idea all the way through. Hope that helps. Talk to you later.